We're going to talk about Nix and AI, and these are topics that have probably been basically plumbed throughout the entire week, regardless of what you were doing. So, but I want to talk about it from a user perspective and that kind of stuff. So, that is way more than one slide at a time. All right, we're going to do it this way. So, basically, AI has every problem that Nix was built for, and this is really fascinating because our AI has all these weird things going on. We have all these LLMs and all this stuff, and we have to figure out what we're going to do with this. So we have dependency chaos. We have a lack of reproducibility in the AI world. In fact, we call that a feature in the AI world. We don't have reproducibility. We have non-deterministic systems now. And that's fascinating, but we still have these problems of how do we run these different models, how do we do training, how do we do inference, all these types of things. And then we have these huge artifacts and these complex setups. And Nix was really designed so that you could get reproducible setups, and that if there was something that was super complex, you could solve it once and have it work in multiple positions, multiple outcomes, multiple platforms, multiple targets. And that's exactly what we want from our AI stacks. So I'm going to be talking about this from a couple different perspectives. In one of these, I will be an ML engineer, and that is when I'm wearing this hat. And in others, I will be me, who's more of a classic release engineer kind of person, and in that, I will not be wearing a hat. So, did I add props for this talk? You're darn right I did. So, I'm Mike Stahnke, like I said earlier. I run engineering and marketing at Flox, and so I do some different stuff. I've been doing more marketing lately, and that's been interesting, but here we are. And over the years, I have been a maintainer of Fedora. I was one of the people that founded Apple. I was a maintainer of Debian. Like, I've done all sorts of packaging. I ported Ruby to AIX. So, you know, I've done stupid stuff. And Nix is something that I only got into a few years ago when I started working at Flox. I was aware of its existence. I wasn't that interested in it. Now I'm sad that I didn't learn it a lot earlier, but, you know, we live and learn. So my main question was, why aren't these ML teams running Nix? Because everybody that I talk to that is doing ML, nearly nobody is running Nix right now. And basically what it comes down to is, okay, so I read this tutorial and it said I'm supposed to use Conda. Okay, so I'm going to go grab Conda and I'm going to go play with this. And then I figured out how to do something, and then it said I needed to do all this stuff using pip. And then it said that I need to build everything from source because there's no other way to guarantee how all this stuff works. But I'm a data engineer and I don't know how to build anything, so that's kind of not going to work super well for me. And then it says that on Linux I need to do it this way, but on Windows I need to do it this way, but I'm on WSL, so I don't even know which ones of those actually apply to me right now. And you just get really, really confused. I have teammates that can train models, and their setup doesn't look anything like my setup. And you know what we do? We don't talk about it, because it's just scary. I can't figure out what they're doing. They can't figure out what I'm doing. We just have to recite the incantations from the great old ones, and then things will happen. So both of these work. Me, my colleagues, we have handcrafted these systems. We have artifacts that are left over from failed Conda installations, virtual environments that are not active, but maybe they're still in the path somehow. We have all of this stuff. But it works, so I don't touch it, because I'm a data engineer, and being a system administrator was not my goal in life. And as a data engineer, I'd like to point out that I've done a lot of really smart things in my life. So I'm not a dumbass who doesn't understand how to do stuff. It's that I have different incentives than what a lot of people do that are very pro Nix. It's not really a skill issue. Like, a lot of these people have PhDs. You know, they're very, very smart people doing all these ML researches. And so they just go find a tutorial on the internet. I go find a tutorial. My colleague finds a tutorial. Is it the right one? We don't know. We just keep trying stuff until it works. I got it working. I'm not touching it. I'm going to leave it alone. When you think about it, that's pretty rational behavior. You've done a bunch of complicated stuff. You finally got something to work. You're not really sure why it worked or how it worked, but you did it. And your job isn't to have a reproducible system, your job is to train a model. Okay? And so every part of the SDLC that has a handoff becomes infinitely more complex because I don't know how it got there. Somebody has handcrafted this thing on their laptop. They've done Python things that are unholy, which in my opinion all Python is unholy, but that's a totally different issue. And so they've done all this stuff, and what happens then? Somebody in some operational capacity, usually, it could be a DevOps team, could be classic ops, could be infrastructure, whomever, says, all right, it's my job to reverse engineer the incantations that this data engineer has taken so that we can put this into something that resembles production. Maybe it's a staging fleet, maybe it's a production fleet, whatever it is, I have to do this. How many people have reverse engineered a data engineer's like stack and tried to figure out what the heck they did? Yeah, I mean I have, and it's super fun. And so basically if you have 2 different data scientists, you have 2 stacks to start with. If you have 3 data scientists, you might have 9 stacks by then. Somehow they multiply. It's a weird math, but it works out. Trust me, I've seen it in real life. And so this conveyor belt of how you do things across the SDLC ends up being built out of duct tape, where you find a solution and you tape it on. You find another solution and you add it in. And so maybe it's a bunch of if statements, maybe it's a shell script that does checking, whatever it is. It's all these different things. But this is where Nix should shine. I need reproducibility. I need a thing that works on one platform or another, one target or another. I don't want to have giant models in everybody's home directory. I'd rather have them in a store path where if they're referenced again, I don't have to install them again. There's all sorts of great things here that we could be doing with Nix. And so you tell your data team to use Nix, and your data engineer says, do you hate me? Did you just tell me? No, we're not going to go down that. So where do I start? Where do I start if I'm a data engineer? I'm supposed to use Nix. All right. I'm pretty smart. I'm a data engineer. I probably have a PhD or something. And they're like, well, first you start with this thing called a derivation. And you're like, cool. I'm going to go back to my abstract math theory classes and go figure out what that means in this case. And you just start hearing other words, store path, derivation, like all these things that seem pretty foreign to somebody that spent their career training models, perhaps writing some Python, mostly doing math. It's a little weird. Do I want to use Nix develop or Nix shell, or I'm supposed to do something so that I can see the header files, but I don't know where the header files are, but I need to be able to link against them or compile or something. And so there's just this complex entry point. The shell and the path feel very unfamiliar. And the way that happens and how this exposes is they go to read a tutorial on the internet, and the internet tells them, you know, you're going to type user bin pip or whatever, and that's not where pip is when you're using Nix. And so you're very confused already. And so a lot of people, they get to a certain point and they just jump off because they're like, I don't know how to apply this into my life. I'm sure this is brilliant, but my job is not to sit here and reverse engineer the way this works. Just like you didn't want to reverse engineer the data stack, the data engineer doesn't want to reverse engineer your Nix. So it's a bidirectional problem in some cases. And these tutorials fail in all these subtle ways because of these hard-coded paths or these assumptions that when you're on Windows it looks like this, or when you're on Ubuntu it looks like this, or they assume that when you say you're on Linux they always assume it's Ubuntu for whatever reason. And that's the way that all these tutorials work. And so the cost of this is that feedback loop is really expensive. You're trying to cycle, you're trying to iterate. All you wanted to do was run a bunch of inference on a model and then run evals and test it and see was it, you know, within bounds or not. And instead, you're spending all this time on infra. And so then, let's say they get that far. I get a data scientist. They get into Nix. They actually think it's cool. They're using it. And then they want to go use some Python thing that isn't in Nix packages, or that's outdated in Nix packages. And that happens, we'll call it 100% of the time. And so now they have to go figure out how to either get something into Nix packages or use the Python things that they need without Nix. And then they get into a religious discussion about purity with their systems team, which again, wasn't their goal. Their goal is to try and train a model and figure out if the model's good or not. That's the entire workload. So these broken guarantees debates, all those types of things with impurity. Like, do they just run pip? What do they do? And so they also need to set up builders and substitutors or whatever if they're going to start building their own packages. And then they eventually realize they become a release engineer and not a data engineer, and now they're mad at you again. So this is why when they say just use Nix, the data teams often don't succeed or don't choose to do that. And their barrier, again, is not intelligence. It's the workflows. It's the ergonomics. And it doesn't mean that Nix is terrible. I'm just trying to look at this from another perspective of you want me to change the way I work so that we have this reproducibility, but this tax is pretty high in the cost of my workload. So there is some good news about some of this stuff. I don't know if you've ever tried to use CUDA with Nix. It's super fun. Flox and the NixOS Foundation and NVIDIA are working on making that way more available. It was in a private kind of GA thing for a little bit. It'll be a little better. But we're still working on it because we know that we haven't solved every use case, we haven't solved every edge case, we haven't solved much of the availability of it depending on what commit you're on in Nix packages and stuff like that. So still coming, but at least there's a dialogue going. It started with a bunch of legal documents, and now we're actually working on the tech part of it, and that's more fun. So yeah, I just talked about that. But it does prove that some of these barriers can move, because I think CUDA being difficult to redistribute, difficult to get going, was a long time problem on basically every Linux distribution. It wasn't related just to Nix, but Nix made it also difficult. And that's getting a lot better. NVIDIA's been kind of seeing the power of their reach and wanting to have CUDA succeed more, and that's awesome. One of the things that you want for this reproducibility is that oftentimes training ends up on GPUs, but production inference actually happens on CPUs, which blew my mind when I learned this because I thought everything ran on GPUs all the time now, but apparently they don't do that all the time. They run a lot of things on, once they have the model all trained, they can actually kind of shrink it, optimize it, get it on CPUs, run it cheaper, I guess. I don't understand that exactly. But you still need reproducibility of here's how I do the training and here's how I do the production deployment. And now you want both of those to be analogous appropriately. So the environmental strategy needs to cover reproducibility for the data engineer, handoffs across the SDLC for the platform type engineer. It needs to cover reproducibility for GPUs or for other targets that are CPUs. So there's just all sorts of stuff there that is not straightforward from a user perspective. And so I have some recommendations on how to handle this. And some of these, I would bet this room doesn't like that much. And I'm going to be okay with that because I say stuff people don't like all the time, so I'm pretty used to it. One is, there's this seam, and you can use Nix and have a lot of power, but inevitably you will run into Python packages that are not available that you wish were. And so the way that I've solved this with people actually doing this work is saying, if it has a C extension, get it from Nix. If it's pure Python, get it from PyPy. It mostly works. The last thing I want to do is download giant wheels. I think wheels are an abomination of a packaging format. I don't know how else to put it. It makes me very sad. So basically, it's not Nixify everything. Don't do everything with Nix, because I think that that is chasing your tail. Like, I just think it's an exercise in futility. I can't mirror all of PyPy and get it into Nix instantly per commit, per change. It's not just use Docker, because that isn't going to get me the Python packages. Like, it just doesn't solve that problem. It just shifts it, the shape. It puts it in a different shoebox. So basically, try and have your own system. Have CUDA, PyTorch, binaries, C extensions, all that kind of stuff. And then start, so basically you own the system native dependencies. And one thing I really like about this is that at least in a Nix shell or in a Flake or in a Flox environment or however you do this, you have your dependencies that are explicit instead of implicit. Because with Python, usually what happens when you try to install something, if it's not a wheel and it needs to link against a library, the way you find out that you needed that library was it fails to install and you read an error message, because there's no way to say, I depend on libxml2 or whatever it is that it depends on. And it's the same problem with JavaScript or Ruby or whatever else. Like that's all there. And so what I've been recommending is UV a lot. Again, I'm not a super big fan of the Python ecosystem overall, but UV seems to be the least worst of all of the Python package managers, and there are only like 28 of them. So, but UV is the one that at least translates into Nix. I think probably the best currently. Poetry is decent, but UV is a little better. And so using UV to Nix, you can actually get more purity there if you have the same set of dependencies that you keep using over and over again, and you don't need to go augment with a different set every day from a different data engineer. So I try and have UV own the pure Python dependencies and try and have Nix own the stack that is native. And then I get some provenance in there because I have the native stack. If I can trace this with UV to Nix, then I get the provenance of the rest of the items after a trust on first use setup, which again, trust on first use has its own set of problems. Not going to get into that one right now. And then I have a practical workflow that I can hand to a data engineer and say, okay, I'm going to give you a dev shell. And it's got all the C extensions you need. It's got Python at the version that we want you to use. It's got the drivers for the GPUs or whatever. And from here, you can type UV and get what you need. That was the goal. And that has worked. Now, the other thing is, because I can get the exact things that I want, I can start to optimize this. Instead of getting this 800 megabyte wheel that has PyTorch in it, I can just go build Torch for the actual GPU that I want and package that up for my consumers. And now I've saved 75, 90% of the disk space that I was going to use otherwise. I find that to be really nice. Some people don't care, but it all depends. Are you out of disk space? Or do you spend a lot on network transfer? Is it just waiting time of things transferring back and forth? It's also faster. Thanks, Tom. And so these AI and ML packages need to stay fresh continuously. This is a priority. If I was going to make a recommendation to the Nix community, it would be how do we keep these Python packages more up to date? And that includes the rest of the AI stack as well. It's difficult to do. Some of this stuff moves super quickly, and I'm super happy when I watch Nix packages flow. Others of it, you might as well be singing happy birthday to the last time it was touched. And it just depends on what package it is. So I guess I would say that I would love to see the community adopt a way to push the envelope on Python specifically because of this ML side of things. Yeah, the freshness is highly variable, as I said. So the better thing is, and the other things are, UV to Nix, I've had relatively good success with UV to Nix. Dream to Nix, I've had maybe less good, but I like the idea of it so much. And right now, most of the time those work, but they can still be a little better. I think they've been kind of in the same state for the last couple of years in my experience, but maybe they've gotten better. I don't use them every day, like I'm not in and out of them all the time, so if I'm wrong on that, I'm sad. And then the final thing is to be friendlier with your ML teams and actually have some empathy and be like, I understand the data you're trying to do or the workloads you're trying to run. I understand the models you're trying to train. I understand what you're measured on. You're not measured on reproducibility. Like, no boss is going to reward that data engineer for having a reproducible environment. It's going to be the model has a success rate of, above a threshold of some kind. And so as an infrastructure person or as a platform engineer, I have to understand that those incentives are different than mine. But my incentive is to make their work as efficient and effective as possible. And so I'm going to help them with that stack. And so you can reduce the shell friction, whether, again, giving them a flake, a dev shell, an environment, whatever you need to do. Give them tools that are handcrafted for them, that are reproducible, that are used, but you've built them for them, understanding their workload. Build some paved roads and really work on improving the UX. Document things. Maybe make your own GPT for it. You can do all sorts of things that can help people. But I find that there's a big barrier between this ML data teams and these platform infrastructure teams right now. They don't talk. They don't see each other as human. They call each other idiots. You don't understand what I'm trying to accomplish. It reminds me a lot of this like dev and ops thing that we used to talk about for a long time. I don't know, it rhymes. And so one thing that I was going to bring up earlier originally, and then I moved it to the end, why that's important, don't know, is that AI actually could help us here. And that's So 2.5 years ago, I didn't know how to write a Nix expression at all. None. Every time I looked at Nix, I questioned so many things about my life. And I just chose ChatGPT. I had a Go project, and I said, hey, build me a Nix expression to package this up. And ChatGPT said, sure, I'll go do that. And then it didn't work. And it said, you're absolutely right, it doesn't work. And I kept working on it. And it took 31 iterations of me going back and forth with ChatGPT to get an idiomatic, very simple Go project packaged. And I was like, well, I don't have to worry about this taking my job anytime soon. I did this yesterday. Same package, or same Go project. I mean, it's been updated a little bit, but basically the same layout or whatever. And I gave it one prompt, and I said, make this a Nix package. That was it. That was the entire prompt. It built the first time, no notes, absolutely worked. It was fine. Was the Nix expression exactly the way that somebody probably wanted to see it? It was pretty darn close, honestly. It was super good. And so from that perspective, maybe the gap between data engineers and platform engineers doesn't need to be as wide, because there's a lot of learning that can kind of be absorbed by other AI tools, or you can help and say, hey, these are the types of prompts that would work really well for the work you're doing, or I can give you a prompt, or I can actually just build a machine that you submit your code and we just spits out the other side a Nix package, and you don't even need to know how it works because I'm doing inference on my end. That's great. And so I'm going to summarize this and let you all go back to ice cream and go to happy hours or whatever it is you all want to do, talk Nix all night. Getting weird. But basically, if we can keep the Python ecosystem and the AI ecosystem as fresh as we can in Nix packages, it's going to lower the friction between data engineers and platform. If we can improve Python getting into Nix through things like UV to Nix or Dream to Nix or other to Nix type activities, that also can make things a lot easier. And if you, as a platform type engineer, which is just a proxy for whatever that role is that's doing those things, can have a little bit of empathy for the way that the data team works, understand their incentives, and meet your users where they are, think like a product person, understand your users have needs, and deliver them the things they need to do their job, I think we can actually make a lot of headway here, and I'm really excited about the space. So are we there yet? No, we're not. There's still a lot of gaps to fill. But the shape of this answer is starting to become more clear to me, and that is that the gap is closing kind of from both directions, where the data scientist is getting a little more familiar with needing reproducibility. The platform engineer is getting a little more familiar with data science because of all the AI stuff that we're all playing with and touching all the time. And these LLMs are actually helping us bridge the gap between the two really, really nicely, because now they can actually write decent Nix, at least for some things. I haven't tried super complicated stuff because I wouldn't know if it was right. I'll be honest. Like, I have not tried to package something like KDE, so that would be rough, I assume. If you want to see this talk, that's where it is. The slides are up. Otherwise, I'm Mike Stahnke. Thank you very much for coming to PlanetNix. And thank your sponsors as well, again. And cheers. Have a great evening, y'all.